All right, section 11.2 is the final way that we're going to be able to solve quadratic equations. So far we've done factoring, that came from chapter 6. Then we did the square root property, which was kind of limited because it only works sometimes when the form is right. Then we used completing the square, which is kind of tedious. And now we're going to come up with a formula. So if you will bear with me, I'm going to show you where the formula comes from. This is not how to use it. This is where it comes from. So this is going to be for free. You don't need to scramble to try to keep up with me and taking notes. It'll be in the video if you want to see it. But this is the derivation of the quadratic formula, not at all how to use it. Then we'll talk about how to use it. Let's suppose that you have a quadratic equation, and I'm going to call it ax squared plus bx plus c equals 0. That would be a quadratic equation because of the x squared. I want to show you how to get this formula. You'll never have to get it for yourself, but I want to show you where it does come from. If I were going to complete the square and find out what x is equal to in terms of a, b, and c, I'd have to get it in the right form for completing the square. Two things. I'd have to subtract c. That would give me ax squared plus bx is equal to negative c. And what else do I have to use completing the square? Doesn't this coefficient have to be a 1? So I would have to divide by a. So what I'm doing is the same process you did, except I'm doing it with the letters a, b, and c instead of numbers. That gives me x squared plus b over ax plus a blank is equal to negative c over a plus the same blank. Okay, now what do I usually do? I take the coefficient of x, which in this case is b over a. I take half of it. That gives me b over 2a. Then I take that number, whatever it is, and I square it, which in this case gives me b squared over 4a squared. That's what I'm going to add to both sides. So I'm going to add b squared over 4a squared. b squared over 4a squared. On the left-hand side, I've created a perfect square trinomial. So what is the binomial squared? What are the factors? X plus b over 2a. I think we talked about that it's always this quantity that you find right here. And that equals, okay, to do this, I've got some fractions to add up. I'm going to make a little cloud and do it up here. And I'm going to turn it around so the positive one's in front. I've got b squared over 4a squared minus c over a. What's the common denominator? Well, we remember from chapter 7, maybe, that you need one of every different kind of factor in the highest power. So I'm going to need 4a squared. There's no change in the first fraction, so it stays b squared. Second fraction, what was a multiplied by to turn it into 4a squared? 4a. So multiply the top by 4a, and you're going to get 4ac. Now I have a common denominator. That is b squared minus 4ac all over 4a squared. So the right-hand side is b squared minus 4ac all over 4a squared. Now remember, you're not ever going to have to do this whole process. This is just showing you how a formula is derived, where it comes from, not how to use it. All right, so now I'm going to use the square root property. That's going to give me x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. Now, if you will, look at just this. Now the numerator, I don't know what the square root of that is, so I'm going to just write down plus or minus shortened radical b squared minus 4ac. But the denominator is a perfect square. What's the square root of 4a squared? 2a. It's not under a radical anymore. So I have x plus b over 2a is equal to this right-hand side. Now I need to subtract b over 2a from both sides. X is equal to, it's going to show up on the right side as negative b over 2a plus or minus the square root of b squared minus 4ac, and that's over 2a. It typically happens that you get a common denominator, so I can just write it once. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. So although you didn't need to write anything else down, you probably should write down that statement. That is what's known as the quadratic formula. And now our lesson in 11.2 is going to be about how do I use that formula to solve a quadratic equation. So I'll give you a minute to make sure you've got it written down. By the way, it is on your blue sheet. And all of our problems have to do with how do you use it. So I'm going to be writing it down over and over every time I need to use it. Everybody got it somewhere? All right. Our problems in 11.2, and I am going to go to a blank page to do these. Problem number 1, because I think it's way too small for y'all to read in class. It says use the quadratic formula to solve the equation. Simplify your answer, type an exact answer, use radicals as needed, use a comma to separate answers as needed. All right, so what I'm going to do for those first 5 questions is just, get a lot of space. And I'll get more space as I need it. So, problem number 1. The equation that I'm supposed to solve is m squared plus 8m plus 12 equals 0. Now let me ask you a question. This is a quadratic to solve. I'm going to use the quadratic formula. But could you factor this? Can you get factors of 12 to add up to be 8? 2 and 6? Okay, so this could be solved by factoring. As a matter of fact, if I write it real tiny over here, m squared plus 8m plus 12 equals 0. Now I'm going to cheat a little bit. I'm going to do this by factoring. And does everybody agree that it's m plus 2 times m plus 6, which means m is negative 2 and m is negative 6. Now that's not what these instructions told me to do. They told me to use a formula. All right, so there's the answer by factoring. Okay, I'm in a torturous mood this morning, so although you don't have to write it down, I'm going to do the problem by completing the square. And I'm going to do it small again. You don't have to write it down. This is just so you realize these are all different techniques that do the same thing. All right, if I did this by completing the square, do you agree that I would have to start out with m squared plus 8m plus a blank would equal, and the 12 would have to go to the other side, so it'd be negative, negative 12 plus a blank. Okay, I'm writing this small. I'm just hoping that you kind of follow along. I would take the 8, take half of it. Half of 8 is 4. Square that for 16. So I would add 16 on the left and 16 on the right. That would give me the binomial m plus 4, quantity squared, is equal to, combining those, I get 4. I would use the square root property and get m plus 4 is equal to plus or minus the square roots of 4. That would be m plus 4 is equal to plus or minus 2. Subtract 4 from both sides, and I would get m is negative 4 plus or minus 2. What do I get when I take negative 4 plus 2? All right, negative 4 plus 2 gives me negative 2. Negative 4 minus 2 gives me negative 6. Okay, now, same problem, kind of working off here in the margin. By completing the square, did I get the same two answers? It was certainly faster by doing it by factoring, but I wanted to show you get the same answers. Now, the third method that we learn is the quadratic formula. So let's go back up. This is what we were really supposed to do. The quadratic formula requires you to know A, B, and C. Now what are A, B, and C? If this is AM squared plus BM plus C equals 0. Now use the letter M like the problem did instead of X. So if that's the truth, what is A? What is the value of A? It's 1. What is the value of B? 8. And what is the value of C? 12. Is everybody okay with that? You need to either write them down or identify them for yourself. You need to know what's A, B, and C. Now, the quadratic formula is, in this case, I'm going to say M equals. It's usually X. The formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So M is equal to, we're ready to plug in the numbers. The number on the outside of the radical says negative B. It always means write down the opposite of whatever the B value is. So do y'all agree it will be negative 8? Plus or minus the square root of B squared means 8 squared minus 4 times the value of A is 1, the value of C is 12, and all of that is over 2 times the value of A, which is 1. Now is everybody okay with just the plug-in of the numbers, A, B, and C? Now what you want to do next is simplify what's in the radical. You're going to need to square this, and you're going to need to find this product. So M is equal to negative 8 plus or minus the square root of. 8 squared is 64. This is a negative 4 times a positive 1 times a 12, negative 48. And all of that is over 2, because 2 times 1 is 2. Now the B squared part will always be positive. The second term, you have to be careful about the sign because it will be the product of these three numbers. And in this case, only one of them was negative, so it was a negative product. So I have M is equal to negative 8 plus or minus the square root of, what do I get right here? 16, and it's over 2. Now, the type of answer you're going to get is totally dependent on the kind of number that's under the radical. If it's a positive number, you're going to get real answers, and if it's negative, you're going to get imaginary answers. If it's a perfect square, you're going to get rational answers, and if not, you're going to have radicals left over. So it all depends on the kind of number under there. What is 16? Perfect square? So m is equal to -8 plus or minus the rational number 4 over 2. And now, because those are rational, I need to come up with my two answers. One of them, what is, I have -8 plus 4 over 2. -8 plus 4 is -4 over 2, which is -2. That's one of my answers. The other one is -8 minus 4 over 2, which is -12 over 2, or -6. Now, I just did this problem 3 times. And did I get the same two answers all 3 times? Yes. When you take college algebra and you learn how to use the graphing calculator, you'll learn 1 or 2 more methods that involve the calculator to get those answers. But basically, algebra students rely on factoring, completing the square, or the quadratic formula for solving quadratic equations. I personally think it's extremely obvious that factoring is the shortest method. The problem is factoring doesn't always work. If the answers are going to be irrational, if they're going to have radicals in them, factoring wouldn't work. So I love it when it works, but when it doesn't, which of these two are you going to want to pick? That'll be up to you. Most people pick this one. It's a little tedious, but not bad. All right, that's the quadratic formula. Let's do it some more. I will not do the other problems 3 ways. It's a promise.
So what happens if the correct answer and you're trying to factor it?
It won't be factorable. It will be the kind of problem that earlier in the course we called prime. So the answers will exist. Factoring just won't get you to them. So you would have to use another method, and we'll see some of those. All right, let's look at problem number 2. It has -8y is equal to 5y squared plus 3. Now, is that in the format that the quadratic formula wants? Quadratic formula, like factoring, wants it equal to 0. So I think I will add 8y to both sides. That'll give me 0 is equal to, I have 5y squared. I don't have any other y's, so I'll just put plus 8y plus 3. I know that some of us don't really like having that 0 on the left-hand side, but it shouldn't matter too much. And turn the whole thing around if you want to. All right, what is the value of A? 5. B is 8, and C is 3. So I have y is equal to the formula, -b plus or minus square root of b squared minus 4ac all over 2a. I have a very bad memory for memorized things, and yet the quadratic formula is one of those things that you just can't forget if you're a math person. I can remember my mom on about her 81st birthday, and she was a math teacher. She could still quote you the quadratic formula. I don't know why you'd want to, but she could. All right, so y is equal to, what is the value of -b, the opposite of b? It's -8 plus or minus the square root of 8 squared minus 4 times 5 times 3. So it was -4 times a times c. And that's all over 2 times the value of a, which is 5. So y is equal to -8 plus or minus the square root of. 8 squared is 64. Negative 4 times 5 is negative 20 times 3, negative 60, all over 10. That gives me y is equal to negative 8 plus or minus the square root of 4 over 10. This problem, you look at the radicand. Can you tell that this problem is going to have rational answers? We're going to have y is equal to negative 8 plus or minus 2 over 10. One of the answers is negative 8 plus 2 over 10, which gives me what? Yes, starting out it's negative 6 over 10, but that reduces to negative 3/5. The other answer, negative 8 minus 2 over 10, is negative 10 over 10, which is negative 1. My math lab, you would give those two answers separated by a comma. So if you didn't like 11.1 part 2, you're probably not going to like this one too much because the answers are going to be very similar. It's just that your work leading to those answers is different. When you get these rational answers, what does that tell you about the original quadratic? It actually tells you it is factorable because the answers were rational. They didn't have any radicals in them. That means that if you had wanted to, if you had been given permission to, you could have factored this. Okay? Let's look at another one. Whoops. Problem number 3. Use the quadratic formula to solve. X squared minus 8x plus 16 is equal to 0. Is this in the correct format for the quadratic formula? Yes. Format for quadratic formula and for completing the square are the same. I'm sorry, I said that wrong. For the quadratic formula and factoring are the same. All right, what is A? 1. B is negative 8, and C is 16. All right, I'm solving for x, so x is equal to the formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to, when it says negative b, and the b value is negative, that means that you write down positive 8 plus or minus the square root of. It is negative 8 in parentheses squared minus 4 times a 1 times a 16. And all of that over 2 times 1. Please stop me, ask a question if you're not sure where a number comes from or how I proceed. So x is equal to 8 plus or minus the square root of. Negative 8 squared. Well, whether this number is negative or positive, when you square it, you get a positive quantity. So that's 64. Negative 4 times 1 times 16 is negative 64. And that's over 2. So x is equal to 8 plus or minus the square root of 0 over 2. I keep making kind of a big deal about the radicand when you're doing this formula because it already tells you what's going on. Well, 0 is a perfect square. The square root of 0 is 0. So this is x is equal to 8 plus or minus 0 over 2. Now, does it make any difference whether you add or subtract 0? No. So actually, we're just going to get 8 over 2 or 4. Now, is it possible that I have a quadratic equation with only one answer? Well, that's all I'm going to report back to MATLAB. X is 4. But what really is going on is that 4 is the answer twice. Because if you add 0, you get 4. If you subtract 0, you get 4. So you are getting 2 answers. But since it's repetitive, there's no reason to give it to MATLAB twice. What would this have, by the way, you notice it's rational? And what that means is this problem was factorable at the beginning. I'm going to take just a second to talk about this. If you had x squared minus 8x plus 16 equals 0, and say you were allowed to factor it, do you agree that it's going to be an x minus and an x minus? It's going to be 4 and 4, which means x is 4, x is 4. So I got the same answer. I got the 4 twice when I did it by factoring, and if I was crazy and wanted to do completing the square, I'd still get 4 twice. Okay, so that happens sometimes when you get 0 as the radicand. Okay, let's look at number 4. Whoops. All right, problem number 4, I'm asked to solve x squared plus 7x plus 4 equals 0. I'm in the right format. I notice that A is 1, B is 7, and C is 4. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Keep in mind that this formula is on your blue sheet, so you should be able to grab it anytime you need to use it. X is equal to, the opposite of b will be negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 4 all over 2 times 1. That gives me x is equal to negative 7 plus or minus the square root of 49 minus 16 over 2. X is equal to negative 7 plus or minus the square root of, what's 49 minus 16? 33 over 2. Now you're always going to want to take a look here. Now the radicand is not a perfect square. It's the first time it's happened to us. It's not a perfect square. Can you simplify it? Whoops. I'm sorry. It's decided to go crazy. All right, question. Can you simplify 33? No, it factors into 3 times 11, but those aren't perfect squares, so that's useless. And what that means is this problem is finished, which is kind of nice. For once, we're kind of happy to get a radical. Oh, yeah. For MyMathLab, you would have to write in negative 7 plus the square root of 33 over 2. Make sure you're out of that answer, comma, negative 7 minus the square root of 33 over 2. Is that okay? And you got answers like this when you completed the square. When you get these irrational answers, answers that have radicals in them, What that tells you is you could have tried as hard as you wanted to factor this, it wouldn't have worked. Back when we were doing chapter 6, we would have said, okay, what are the factors of 4 that add up to be 7? And we would have said there aren't any, so this is prime. And when you would have written down prime, what that means is the answers would have radicals in them. Can't be done with rational numbers, which is what you do with factoring. Okay. Number 5. I have 5m squared plus 2m equals 11. Is this quadratic in the right form for the quadratic formula? No. I would have to bring the 11 back over on this side, so I have 5m squared plus 2m minus 11 is 0. A is 5, B is 2, and C is negative 11. Okay, why don't I be real quiet and let you solve this one. We will talk about it because I think we'll have to simplify the radical, but we're going to pause for a minute. I have gone ahead and put in the quadratic formula. So m is equal to, it should be negative 2 plus or minus the square root of 2 squared minus 4 times 5 times negative 11 all over 2 times 5. So just substituting in the numbers. All right, that's going to give me m is equal to negative 2 plus or minus the square root of 2 squared is 4. Now this time I have a negative times a positive times a negative. Because there are 2 negative factors, did you have it as positive? So that's going to be negative 20 when you multiply the first, and then negative 20 times negative 11 is positive 220. And that's over 10. So I have m is equal to negative 2 plus or minus the square root of 224 over 10. Now 224, I'm just guessing that maybe we can simplify that. What did you get as factors of 224? 16 and 14? Okay, so 16 and 14, you might have started out playing with the number 4 and then gone from there. So that is 4 times the square root of 14. You want to make sure that you factor it with the largest perfect square. Back to the problem. M is equal to negative 2 plus or minus 4 times the square root of 14 all over 4. Did I do something? 10. Okay. I don't know where I got that. Made that number up. Thank you. Okay. This rational number, this rational coefficient, and this rational denominator all share a common factor, which means that this answer, this fractional answer, can be reduced. Do you agree 2 goes into all those? So 2 is going to go in there negative 1 times, 2 is going to go in there 2 times, 2 is going to go in there 5 times. M is equal to negative 1 plus or minus 2 times the square root of 14 all over 5. I'm completely happy with that, but of course MATLAB will want the 2 distinct answers. It will want negative 1 plus 2 times the square root of 14 over 5, comma, negative 1 plus, minus 2 times the square root of 14 over 5. Okay, let's look at number, I need to just say something about number 6, even though it doesn't have weird answers. Here's number 6. It is 1/9 y squared equals y plus 1 over 36. We might have been in big trouble if I had completely skipped this one. All right, my goodness, I do not want to let a be 1/9. Even when I get this in the right form, I don't want these fractions for a, b, and c. This is an equation. I have the right to multiply by any number I want. Could I multiply by the least common denominator of these fractions? And what would it be? 36, actually. 9 is the common factor. 36 is the common multiple. So I would multiply by 36. It would be 36 times each one of these. And what that would end up giving you, 9 goes into itself once, 9 goes into 36 4 times, so you would have 4y squared is equal to 36y plus the 36 divide out, and I get a 1. Could you now put this in what's called general form? Could you set it equal to 0? Wouldn't it be 4y squared minus 36y minus 1 is equal to 0? This is the quadratic that you should begin the formula with. Okay, and I've written the word change there. And now you could identify A, B, and C. You could have done the problem with the original A, B, and C, but it would have been horrible. All right, let's look at number 7. Put it down here.
That's it.
Well,
After that, you do problem.
and then do the problem. So it would be now start. So you'd have to do that before you could get going. All right, problem number 7. It is x squared plus 8x plus 20 equals 0. It's in the right form. A is 1, B is 8, C is 20. So I'm going to have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to, opposite of b, negative 8, plus or minus the square root of 8 squared minus 4 times 1 times 20, all over 2 times 1. That's going to give me x is equal to negative 8 plus or minus the square root of 64 minus 80 all over 2. X is equal to negative 8 plus or minus the square root of, what's 16 minus 80? Negative 16, and that's over 2. This time the radicand is negative. What does that tell you about the answers? They're going to be imaginary, because I'm going to try to take the square root of a negative number. It's going to be imaginary. So x is equal to negative 8 plus or minus, what are the square roots of negative 16? 4i over 2. So that should, the negative 16 should tell you that you're going to get imaginary. And now you reduce it because the rational numbers all share a common factor. Divide those by 2, and you should get negative 4 plus or minus 2i. Are you going to put it over 1? No. So I divided 2 into each of those, and you don't write a denominator of 1, which means in my math lab, you're going to have negative 4 plus 2i, comma, negative 4 minus 2i. When you get to this stage in your quadratic formula problem, you look at the radicand. If it's a perfect square, you're going to get 2 rational answers. If it's 0, you're going to get 1 answer. It's really a repeated answer. If it's not a perfect square but it's positive, you're going to get irrational answers. If it's negative, you're going to get imaginary answers. In college algebra, you'll talk more about that. All right, let's just look at the problem on number 8. I'm not going to do all of 8. I want to go back and look at the problem. The problem starts out as x minus 4 times x plus 2 is equal to 8. Can I come close to identifying A, B, and C in this format? What am I going to have to do? FOIL. Oh, yeah. Those factors are useless. We've got to multiply it. That's going to give me the product of the first is x squared. The outer product is 2x. The inner product is negative 4x. Positive 2x, negative 4x gives me negative 2x. Negative 4 times 2 is negative 8, and that's equal to 8. Is it ready yet? No. I'm going to subtract 8 and get x squared minus 2x minus 16 is equal to 0. Now, start. Now you can identify A, B, and C. All right, last one. Let's go ahead and I'm not going to finish number 8. Number 9. Whoops, there we go. It starts out as 8 is equal to negative 4x squared plus 9x. Is it in the right format? No. Now, you have a choice, and it really doesn't matter which way you do it. You can subtract the 8 and bring it over here, or you can add 4x squared, subtract 9x, and get those terms over there. It doesn't matter. Now, it's fewer steps to move the 8. But I've got to tell you that math people have a tendency to have almost an aversion to the coefficient of the x squared term to be negative. Do you remember when we did factoring common factors? If that was negative, we factored out a negative something, a negative 1 or a negative something. We just don't like the coefficient of x squared to be negative. Is it wrong? No, we just don't like it. So I'm going to choose to add 4x squared to get it to this side. And I'm going to subtract 9x to get it to the left side also. That leaves me with positive 4x squared minus 9x, then there was a plus 8 equals 0. If you had it all on this side, it would be negative 4x squared, positive 9x, and negative 8, but in the end, the answers would be the same. So the way I'm doing it, A is 4, B is negative 9, C is 8. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. If you actually write the quadratic formula down every time you use it, you'll have it memorized after the lesson, even though you don't have to. Negative b, well, what's the opposite of negative 9? Positive 9. Plus or minus the square root of negative 9 in parentheses squared minus 4 times 8 all over 2 times 4. X is equal to 9 plus or minus the square root of negative 9 squared is 81. All right, negative 4 times positive 4 is negative 16 times 8 is something kind of big. Would you tell me what it is? Negative 120? 124? 128, sorry. That is all over 8. So I have x is equal to 9 plus or minus the square root of, what is 81 minus 128? Okay, negative 47, and that's over 8. Remember, the kind of number you have right here tells you the kind of answers you're going to have. If you have the square root of negative 47, now 47 is a prime number, so that's not going to simplify, but what about the negative piece of it? Doesn't it come out as an I times the square root of 47? I just can't do anything with the number 47. So that gives me x is equal to 9 plus or minus I times the square root of 47 all over 8. Done. Except where MATLAB is concerned. Which wants 9 plus I square root of 47 over 8, comma, 9 minus I square root. Why does it always do that to me? Okay. It's cranky this morning. It was negative 47, and I changed it to I times the square root of 47 over 8. Okay, that's the quadratic formula. Because it's a formula, it's easy to program. If you happen to be a programmer, you could pretty easily write a little program, and the program would say, what's A, what's B, what's C, and it would pop out the answers. Okay, I actually have that program on my graphing calculator. I'm not going to share with you because I want you to know how to do it, but it's not a really hard thing to program. So we're going to call it quits on the quadratic formula.